Okay, so now we're into some more examples here. So for this one, we can look at the amplitude. Again, amplitude is found out front, so amplitude of 2. Our period is still 2 pi divided by whatever's attached to the x. So 2 pi divided by 2 gives us a period of just pi. Our phase shift, now we actually have something in here. Okay, so we're going to take that 2x plus pi. We're going to set it equal to 0. So we have 2x equals negative pi. So we have x equals negative pi over 2. That's our phase shift. We'll talk about what that means in just a second. And then lastly, vertical shift, you have one of these also. It's at negative 1. Okay, next question, what trig function are we talking about? This is the cosine function, so we think about starting 0, 1. At the first one, we drop down to 0, then to negative 1, then to 0, and then back to positive 1. We do not have a vertical reflection that we have to worry about because the 2 out front is a positive, so we're good. It's going to look something like that. Okay, so the next thing we need to do is build our graph. So to start that, we're going to still start with the vertical shift. So we start with our vertical shift. It says down 1, so we go down here to 1. We draw our little dotted line. And remember that that dotted line is going to behave like the x-axis from up here. So vertical shifts move the x-axis up or down. Now we have this phase shift to talk about. The phase shift says that we're going to start our graph at negative pi over 2. So here's 0. Here's negative pi halves. So I'm going to draw a vertical line. And this is going to behave like our y-axis. So this is the one tricky part about phase shifts. It affects how we split up our graph in terms of the period. So the period is still pi. So we're going to take the period and we're going to add it to the phase shift to figure out what my end value is going to be, what my furthest place over is going to be. So the period was pi, and we're going to add it to negative pi halves. If we did that, this is like 2 pi halves plus negative pi halves. So this will be positive pi halves. So we're going to end our graph at positive pi halves. So we really didn't need all this extra space to the right. Okay, our next job is going to be to split this chunk of x values into 4 little pieces. So halfway in between negative pi halves and pi halves is 0. So that's going to be one of our values. And then if we split this guy into quarters here, this is negative pi fourths and then positive pi fourths. You can still take the period and divide it by 4 to figure out what you should be adding to the original phase shift. So if you started with your phase shift of negative pi halves and you added pi fourths, you would get to negative pi fourths, which is the next little tick mark. So that's how we get to this number. And then we would add pi halves to that, pi fourths to that to get 0, which is the next little tick mark on our graph. And then if you added pi fourths to that, you would get over here to pi fourths. And then if you added pi fourths to that, you get to 2 pi fourths, which is pi over 2. That's the last value. Okay, so now the hard part's over. All we have to do now is adjust our amplitude really quickly. So amplitude was 2. So from the vertical shift, we go up 1, 2. So our max is going to happen at 1. And from the vertical shift, we go down 2. So our min is going to happen at negative 3. And then we just think, what does cosine look like? Well, cosine starts at the top. It starts on a max. So at the phase shift, this is where you start. So we're going to go from the phase shift, we're going to go up to the max right here. Okay, next tick mark, we go to 0. Okay, we're going to this guy right here. So that's our -1 that we have. Then the next thing that we have is a minimum value. So we're going to drop down to the -3 on the next tick mark. Then on the next tick mark of the period, we're back to 0, or in this case, -1, because that's where our shifted x-axis is. And then for the last tick mark, you're back to the max. So you're back up to 1. And then we can connect that to create our cosine curve. Okay, let's think about what a sine graph looks like. So sine of 0 is 0. First section, we reach a peak. Second section, we're back at 0. Third section, we're at a min. And then fourth section, back at 0 to create this nice, pretty sine curve. Well, one thing to notice, we have a negative out front. That means that we have a vertical reflection, meaning that we're going to take our sine graph and we are going to flip it. So 0, 0 stays, but +1 comes down, 0 again. Then -1 goes up and back to 0. Our graph at the end should look like the blue graph. So we need to keep that in mind when we go to graph our function. All right, so our amplitude is the absolute value of whatever a is. In this case, it's -1, so our amplitude is 1. Okay, next thing is the period. We're going to take our standard period of 2 pi and divide it by the number in front of x, which is 4. 2 pi divided by 4 is pi over 2. Okay, our phase shift, we take the entire input, 4x minus 3 pi, and set it equal to 0. We add the 3 pi over, we divide by the 4. This means we're going to start our graph at 3 pi over 4 on the x's. Okay, and our vertical shift, last thing, is a +1 in the back, meaning that we're going to pick up the x-axis and move it up 1. All right, so in the last example, we went ahead and had the graph drawn out, and I have some spacing issues because I didn't create my sections first. So you have the option to create your sections first because you know where it starts and you know the length of the period. So for our sections, before we even do the graph, we know that we start at 3 pi over 4. That was our phase shift. Okay, to find out what to add each time, we're going to take the period, which is pi over 2, and we're going to divide that by 4. To divide it by 4, that means that we're going to multiply it by a fourth. So we're going to add pi over 8 to our phase shift until we have completed a period. Okay, so first tick mark will be at 3 pi over 4. The second tick mark will be at 3 pi over 4 plus pi over 8. If we got a common denominator here, this would be 6/8 plus 1/8, so 7 pi 8ths for the next one. And now we can kind of count by pi over 8ths to get the other sections. So our third section will be 7 pi 8ths plus pi 8ths, which is 8 pi 8ths, which is 1 pi. And then our fourth section will be 8 pi 8ths plus pi 8ths. So we're at 9 pi 8ths. And then if we go one more, because technically there are 5 lines here, there's the one that is usually the axis, then 2, 3, 4, 5. It creates 4 sections because the sections are what's in between. Okay, but the actual tick marks, there's 5 tick marks. So we take that 9 pi 8ths and we add one more pi 8ths to get 10 pi 8ths, which is really 5 pi 4ths. Okay, we should also be able to verify that we did this correctly because the distance between the original phase shift and the ending tick mark should be pi over 2, the period. So if you took 3 pi fourths plus 1 pi over 2, which is really like 2 pi over 4, we do end at 5 pi fourths. So you can see that we have a match. We did all of our addition correct. It's not a bad idea to check yourself that way. Let's go ahead and set up our graph and finish it out. Okay, I know that we have a vertical shift of 1, so we're going to move up 1. We're going to draw our dotted line through there to represent what we're going to think of as the x-axis, to represent this guy right here from the sine graph. Okay, next thing we have, we can go ahead and deal with the amplitude. Amplitude is 1, so we go up 1 from here, which puts us at positive 2, or down 1, which will put us at 0. Next thing we want to deal with is the phase shift. We're going to start at 3 pi fourths. And to show that we're starting there, I'm going to use another dotted line right here to give us kind of a reference. And then we know all of these other points. The first one is 7 pi eighths. Then we have pi. Then we have 9 pi eighths. And then we have 5 pi fourths. And that creates our 1, 2, 3, 4 sections. Okay, so sine graphs start at 0, 0. So that's this point where our two dotted lines intersect. And then remember that since this is a vertical reflection, we're going to go down first. So we're going to hit a minimum and then bounce back up to the axis, hit a max, and come back down to the axis. And we get this nice, beautiful sine curve, which you could continue. Remember that it keeps going in both directions.